All right, Math 1, Unit 6.2, Measures of Central Tendency. Measures of central tendency are mean, median, and mode. You've probably heard of those before. First, we'll start with mean. All right, mean is average. The mean is the sum of all the data values divided by the number of data values. Okay, and the best time to use mean is when there is not any outliers, and we'll talk about outliers in a minute. So let's go down here, and I guess maybe we should mention outliers right now. We can see an outlier is a data value that is much greater than or much less than the other values in the data set. And I'll show you how that affects the data set in a minute. But let's go ahead and figure out what the mean is of these 8 bowlers. Remember, mean, you add up all the data values and then you divide by the number of data values. It's simply the average. So on this one, one thing I want you to think about before you start doing any measure of central tendency, mean, median, or mode, you want to take your data set and put it in order. So we're gonna rewrite these in order. 104. 104, you guys should be doing this with me. 104. And then what's next? 109. Then it looks like 113. And then 117. And 136. And finally 189. Now you don't have to do this in order to find the mean, but it does help with the median, and it doesn't necessarily affect the mode, but it will help. It's easier to find it when they're all in order. Okay? So let's start with the mean, as I said. Remember, the mean is the average, the sum of all the data values divided by the number of data values. So we'll simply add them up. These calculators are really helpful. So let's see what we got here. Can you guys see that? It's 104 plus 104 plus 104 plus 109 plus 113 plus 117 plus 136 plus 189 for a total of 976. Okay, so let's write there 976 divided by 1, 2, 3, 4, 5, 6, 7, 8. And when we do that, divided by 8, we get 122. Okay, so that's the mean. All right, that's the average of all of your data set. You add them all up and you divide by the number. Any questions on mean? Okay, let's go back and look what median is. The middle value in a data set when the values are arranged in order. For a set containing an even number of data values, the median is the mean or average of the 2 middle values. Okay, so let's go back and look at our data set, and this is why we have to put them in order if we're going to find the median. So we've already put them in order. We count, there's 1, 2, 3, 4, 5, 6, 7, 8 data pieces. So since there's an even number, you have to take the middle 2, which would be the 5th and 6th pieces. So to find the median of this data set, I'm going to add 109 plus 113, and then I'm going to divide by 2. I'm going to find the average of the middle 2, or the mean of the middle 2. And let's see what we got here. 109 plus 113 is 222, which means when we divide it by 2, we get 111. So the median is 111. Any questions on median, the middle term? You think about like probably on Herndon out there, if you guys have been going down Herndon, you know there's the island. A lot of times they have trees or bushes in the island, okay, in the middle of the road between the, in that case it would be the eastbound and westbound traffic. Well, that is really what that's called, is a median, the middle. Okay, the middle or the island. Median, the middle terms. Okay, or the middle values. Questions on that? Okay, mode. Let's go back and read the definition for mode. The mode, the data item that occurs the most times. A data set can have no mode, one mode, or more than one mode. And over here, you notice both the mean and median are affected by outliers. Remember, an outlier is a data value that is either much greater or much less than the other values. But use the mode when the data are non-numerical or when choosing the most popular item. Mode are not affected by outliers because the mode is just what happens the most often. Okay, so let's go back up here and look at mode. What's the mode of this data set?
104.
Yeah, 104. Okay. Now, take a look at our data, 104, 104, 104, 109, 113, 117, 136, 189. Which of these three, 122, the mean, the average, 111, the median or the middle value, or 104, what do you think is most representative of our data set?
111.
111, how come?
Because it's in the middle.
It's in the middle, okay? You can see we've got 4 below it, 104 through 109, and 113 to 189. Anybody have a different opinion? Okay, I think median's a good one, but if you look at it, there are, all the way down to the smallest is 104. That's only 6 less than the median. But if you look at the top one, that's, what is that? That's 78 more than the median. So from here to here is only a difference of, what, 5? From 104 to 109, only a difference, 111. So only a difference of 7, right? From here to the median is only a difference of 7. But up here, there's a difference of 78. So a lot of spread on this side and not much on this side. So maybe the median isn't the best. Maybe some people would say the mean because, the mean is right about here, which seems like it's more in the middle of these numbers. But if you look at the mean, it's way over here. There's only 2 values that are above it and 6 below it. So maybe the mean isn't the best. Maybe the mode is the most representative because really almost half the team is right around the mode, isn't it? So what I'm trying to point out here is there's not a specific yet right or wrong answer when you're talking about which one did you want to use. It really, what it comes down to is what are you trying to prove? If you're trying to prove the team isn't very well, you would probably argue isn't very good, you would probably argue that the mode is the best and most representative of the data. If you're trying to prove that the team's pretty good, you probably want to argue that the mean is the best representative of the data. So, depending on what you're trying to prove, might affect which of the 3 measures of central tendency you use. And this is why it's important for you guys to understand this stuff as an adult. This is one of the units that actually is pretty helpful for you because people use statistics to prove what they want to prove. All right? If you ever read the paper, 2 different groups could use the same statistics to prove completely different things. So that's why you have to be very skeptical when you read things. And you've got to decide when you read something, what does this person want me to believe? Okay, and are they taking the facts that they want to talk about? When you read about political stuff, the Republicans will tell you one side and the Democrats will tell you the other side. Who you want to believe, you have to read both sides and kind of figure out, which seems like the most logical or the most truthful to you, right? So this is why it's good to understand this stuff. Any questions? All right, so which measure of central tendency best describes the score? Well, we could probably find an argument for any one of those. And I think the way this data is set up, it is pretty hard to decide which one is best. All right, so Bowler number 9 shows up and scores 280. Wow. How would this affect the measures of central tendency? So let's go ahead and let's find the mean, median, mode with this new outlier. Let's add this guy out there, 280. And let's see how they change. So we had 976. So to find the new mean, all we have to do is take 976, add 280 to it, and then divide by 9 this time. And we get 139.55. I'm just going to call it 140. So you can see that that outlier really affected the mean, didn't it? And this is why we say that up here it says, use the data used to describe the middle of the set of data that does not have an outlier. So this is why we don't use the mean as much when there are outliers, because you can see how much an outlier affects the mean, right? All right, the median. Let's take a look at the median. Well, now our data set has 9 pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, which means our 5th data piece will be our new median. You can see that the median is less affected by an outlier, isn't it? So this says use to describe the middle of the set of data that does not have any outliers. But it does work best when there's no outliers, but you can see that even though there is an outlier here, the median doesn't change as much as the mean, does it? Okay, so sometimes if there's an outlier, the median is probably better to use than the median. Excuse me. Sorry, the median is still probably better to use than the mean, isn't it? A lot of M words today. All right. Now, how is the mode affected? What's the mode? Has it changed?
No.
No, the mode is unaffected by it. So that might be an argument that the mode is the most representative of it. Okay?
Yeah.
Questions on mean, median, or mode?
No.
Question on outlier. Okay, so far so good then. All right, so your grade on 3 exams are 80, 93, and 91. What grade do you need on the next exam to have an average of 90 points on the 4 exams? So this is, pretty common. You guys do this at the end of every semester, right? I tell you what your current grade is, and you say, what do I need on my final to get an A, a B, or a C? So this is basically what we're doing here. Now, what do I need on my final is a little more complicated in math because different things are worth different values. So it's a little more complicated than this. But if you had a class where you just take 4 exams and the average of the 4 exams or the mean of the 4 exams ends up being your final grade, which does happen in college quite a bit, you could use this example to find out what you need to get your desired grade. So your first 3 tests are 80, 93, and 91. And you haven't taken, you haven't taken your 4th test yet, have you? So we're going to call that X, because that's your unknown value. And at the end of the class, you'll have taken how many tests?
4.
4. And you're hoping to have a test average of 90, aren't you? So that's how you would set that up. Does that not make sense? If you had a class that was based on 4 exams, you would add up the 4 exam scores, divide by 4 to get your grade, wouldn't you? Okay, well, you've taken 3 of the 4 exams, and you want to know, what do I need on that 4th exam to get a 90 in the class? Would be a pretty common question. So first we're going to add up the 3 scores that you have taken, 80, 93, and 91. And you have 264 points so far. So if we simplify this, what we get is 264 plus X equals 90. Right? Okay. So, oops, I forgot something. 264 plus x divided by 4, right? All right, so last semester we talked a lot about cross multiplying. This is a really great technique that we use quite a bit in math. So if I put 90 over 1, now I have a fraction equal to a fraction. And hopefully you remember we said anytime you have a fraction equal to a fraction, we can cross multiply. So if I multiply 264 plus x times 1, I didn't do a very good job. I'm going to bring this all the way over here. If I cross multiply 264 plus x times 1, I just end up with 264 plus x, right? And now if I multiply 90 times 4, well, 9 times 4 is 36, so 90 times 4 is 360. So after cross multiplying, I end up with 264 plus x equals 360. Does that make sense? Yeah? We good?
Yeah.
Okay. Now all we have to do is subtract 260 from both sides, 264 from both sides. And we get x equals 96. So you're going to need 96 on that last exam, and if you plan to get an A in the class. Okay? What killed you is that 80, right? That 80% is what made it so difficult for you. Any questions on that?
No.
Okay? Let's go to the back page. All right. So, the last thing we want to talk about today is what we call a line plot, or sometimes called a dot plot. And it is just a way to organize your data, kind of like our frequency table yesterday. So a line plot or a dot plot is a data display which each mark above a number line corresponds to each data value. So it's very much like a frequency table. The results of a survey on the number of televisions in students' households are shown in the list below. Okay? Construct a line plot of the data. So the first thing we want to look at is what's our fewest, our smallest data value, 1, and our largest is 5. So all we do is we go 1, 2, 3, 4, 5, all of our possible data, and then we just start here and we start making an X. 1, 3, 4, 3, 3, 5, 3, 2, 3, 2, 3, 1, 4, 5, 2, 4, 4, and 2. Okay, so the next question is the data uniform, symmetric, or skewed? What does that tell you about the mean and median?
Symmetric.
It's symmetric, so what do you think? You can pretty much draw a line right through it, right? And you can see how it's actually perfect symmetric. We have 6, 4 on each side, and 2 on the outside. So it's perfectly symmetrical. So what do you think that'll tell you about your mean and your median?
Are the same?
They are the same in this case. And if you had another data set that wasn't as perfectly symmetrical as this, but when you have symmetrical data, it tells you your mean and your median will be very close to the center values. When your data is symmetrical, your mean and your median will be very close to your central data. And in fact, most likely your mean, median, mode will all be very close to your central data. Okay, and in fact, in this case, your mean, median, and mode are all 3. Okay, obviously if we averaged all these, you'd get 3. The median clearly is 3, and the mode is clearly 3. So when your data is symmetrical, mean, median, and mode will most likely be very close to the central data piece. Okay? All right. A couple more things. So the measure of dispersion. You guys know what dispersion is? Okay, disperse. Okay, when a crowd disperses, they spread out. Dispersion means the spread of the data. And what we use to find out how big the dispersion is what we call the range. Okay, the range of a set of data is the measure of dispersion. That is the difference between the greatest value and the least value. So in this case, if we look at our data here, what's our biggest data? The most television sets in one house is 5. The least is 1. So our range here would equal 5, the largest data piece, minus 1, the smallest data piece, for a range of 4. So the range is 4 here. Obviously 5 minus 1 is 4. You can see 1, 2, 3, 4. Questions on range? All right, let's do the last question together real quick. All right, so we have stock A and we have stock B. Let's say stock A is Apple and stock B is Android, right? Okay, so we got Apple phones, we got Android phones. So the stock, as you guys hopefully know, that like you heard of the stock market, and Apple, in order to do all the things they do, they sell stock in their company. Okay, and that way, that's how they get money to make new products. And for investing in their product, the stock values go up and down, and people try and buy it when the stock is low and sell it when the stock is high, and that's how people make money. Okay? So let's take a look at the mean and the range of stock A. So I'm going to add up to find the mean. As you remember, hopefully, you add up all the data pieces and divide by the number of data pieces. So in this case, we're going to add them all up and divide by 5 to find the mean. So 25 plus 30 plus 30 plus 47 plus 28 equals 160. Divided by 5 is 32. So the mean here is basically $32. On average, you could say the Apple stock sells for $32. Okay? And what's the range? Well, that would be 47, the highest price that it sold for, minus the lowest price, 25. And what do we get there? 22? Okay. So the range of prices goes $22. So it moves around quite a bit, doesn't it? Goes up and down. Apple comes up with, the iPhone 11, stock prices go up. Everybody's excited about Apple products, so their stock prices go up. iPhone 11 comes out, and then this has happened before. There's some glitches in the phone, right? They aren't working right. So stock prices drop dramatically. So because Apple comes out with some really neat products and then they don't always work right, their prices go up and down. Does that make sense? Okay, let's take a look at Android. So Android prices are, again, we're going to add all these together and we're going to divide by 5. So let's see what we got. 34 plus 28 plus 31 plus 36 plus 31, and we get 160 again. And divide that by 5, and we get 32. So the mean in stock B, the Android phone, is $32 as well. So you might say, well, there's no difference. I could buy Apple products, I could buy Android product, doesn't matter. Their stock value on average is both $32. Now let's look at the range. Okay, the range is 36, the highest stock value, minus the lowest, which is, looks like 28, for a $8 range. Well, the range is quite a bit different, isn't it? $22 to $8. So, which stock would you rather own? Android? How come Android?
Yeah.
It's cheaper. On average, it's the same price.
I'll stop.
And in fact, the lowest price Apple sold for was $20, $5. The lowest price Android sold for is $28. Why would you rather have Apple? You can make more money off of it. Okay, so let's say that these were the days they sold here. So if you bought Apple on February 1st for $25 and held on to it for till February 4th, and then you sold it right here, how much money would you make? You'd make $22. And then guess what? If you waited until the next day, you could buy actually almost two stock, right? So you bought one stock for $25, sold it on the 4 days later, and then for an additional $3, you could buy two. So you've actually almost doubled your money, haven't you? Okay? Well, that doesn't seem like that big a deal. You made $25 or $22 in the transaction. But what if you bought 100 stock? Or what if you bought 1,000 stock? Okay, so that'd be, maybe you put $25,000 into Apple on February 1st, sold it for $47,000. You've almost doubled your money. Okay, so then if you, for $3,000 more, you could buy twice as much stock. And what if it jumped up to 47 again the next day? You just made about $80,000. Or excuse me, you just made about $50,000 in a matter of 6 days. Not too bad a deal, right? All right. Did anybody make an argument why you might want to own Android stock? No? No? There you go. The chances of losing money, it's just kind of slow and steady, right? It bounces around a little bit. So you're not going to lose a lot of money. No, you're not going to make a lot of money, but you're not going to lose a lot of money either. Okay? Now, so let me talk to you a little. I'm not an economics teacher, so I'm certainly by far not an expert, but just the very basics. I think I've told you guys how my goal is to put $5,000 in the stock market for my grandkids the day they're done, right? Day they're born, done. Day they're done cooking. Okay? So, if I can do that, they have from 0 to, let's say, 65 when they retire. That's a long time for that money to sit in the stock market. And what's going to happen is, if you can see it down here, the stock market's going to go up, it's going to go down, it's going to bounce around. It might be some crash, but it'll go back up. And, this might be a little dramatic, but the stock market will react like that, right? That's how basically the stock market works. It loses money, it gains money, it loses. But in general, if we drew a straight line through it, generally it's going up, right? So if you got 5,000 and you got about 60 years to leave your money in there, that 5,000 could turn into an awful lot of money in 60 years. Okay? My grandchildren won't need that money until they're in their 60s, is my plan at least. So they can afford to lose a big chunk of money right here because they know they're going to come back and get it back. And they'll lose, and they're going to lose several different times throughout the course of their life. But in the end, they're going to have a lot of money. And at this point, they're working, right? They're raising a family. They're earning money. This money isn't really important to them right now. But when they retire, they're not going to have an income anymore, are they? Okay, so when they're working, they can afford to lose and gain and lose and gain. It's not a big deal. So they would probably want to own Apple stock that's going to gain money and lose money and gain money, but it's going to grow. But when they retire, what most people do is they convert their stocks into bonds. Okay, bonds are basically the government sells bonds. They say, hey, if you buy this bond from us, we'll give you a little bit of money back every year. They're guaranteed. you're not going to lose money. Okay? And the government does that because they want to build things like different projects, highways. They want to do some work. So they sell bonds and they guarantee people who buy them a little bit of income every year or every month. They're very slow and steady. You don't make a lot of money off them, but they are guaranteed profit. Okay? That's what most people do when they retire, because now they have their chunk of money and they don't need to make a ton. They just want to make sure they have a nice monthly income. So they convert their money they've earned in the stock market over the course of their life into bonds that are very safe and to more steady stocks that we can count on, that we know aren't going to lose us a lot of money. And now those stocks don't make a lot of money over time, but they're steady and they're more guaranteed. Because when you're old, all you want to do is know that you've got a nice steady income. Does that make sense?
Yeah.
Okay. A little lesson on that. If you guys remember September 11th, 2001, right? Okay, well, I started off, I had a little stock market, a little investment every month. I just started off putting $100 a month in. And because the stock market was doing very well, within about, I started that back in about the early 90s, right around 1990. So in 11 years, my $100 a month had turned into almost $50,000. Not bad, right? Okay. But then, on, let's say, September 10th, 2001, I had about $50,000 in there, right? Pretty good. Guess what happened the next day? 9/11. And literally, overnight, my stock went from about $50,000 to about $25,000. I lost half my investment. Okay? But again, I was still pretty young. I wasn't really worried about it at that time. It was 18 years ago. And what happened was my money came back because America is America, and we, believe in the future, and everybody started investing and rebuilding and doing things, and my money came back actually even faster and got back up to where it was. In only a couple of years, it was back up to where it was right here, and then even grew. And then it steadied out, okay? But my money came back very quickly. I had time, right? I was young. I didn't have to worry about it yet. So I was able to stick with it, stay the course, and my money eventually came back to where it was and even better, right? Well, there were a lot of people right here on September 10th that were getting ready to retire. Okay, they were done earning. They were done playing the stock market. They were ready to retire and put their money into this safe area. But guess what? They didn't get to, and they lost a ton of money. And a lot of older people on September 11th lost their entire savings, or a good chunk of it, and weren't able to retire. And they had to go back to work or continue working. So that's the dangerous part about playing the stock market. You got to know when to get out. Unfortunately, who could have seen that coming? Right? All right, there's your economics lesson for the day and your math lesson for the day. Your job is to do the odds 1 through 9. Just the odds on 6.2. All right? Any questions?